everything you can do on Windows, the registry, lots of cool stuff, GUI, that kind of stuff. Networking of Weissman, Fin, more like Power Machine broke, you know, better technical difficulties. But what is next? Well, all these things have to run something called a service. And what is a service? On Linux, we would refer to a service as a daemon. We're talking about a process that runs independent of a logon, so you don't need to be logged into the machine for the service to be running. And it usually listens on a port, like Weissman mentioned last week. So like SSH will listen on port 22 on TCP protocol. In Windows, services are pretty close to the same as Unix, and usually they can only be a single instance of a specific service. I mean, you can make copies, but usually a service is only run once on a machine. How Linux does services? So they're controlled by an init process. It's the first process started, and all other processes are children to that process. It has a PID or process ID of 1, and usually this is systemd unless you're on Alpine or some other unknown fruit-related distro. The syntax for systemd is pretty simple. Just use systemctl, a verb, and then the service you want to apply that verb to. So start obviously starts the service. Stop, obviously, you know, enable or disable. Usually make it so that you can either start or stop it. And status, which is, you know how the service is doing. And if you want to list or get a list of all the loaded services, so systemctl tac types equals service, we get you a nice big list of, probably pretty long list, of most of the loaded services on the machine. Windows, similar to Linux, usually there's only a single service that rules them all. The service control manager, it's pretty sick. Every service uses it. They make fun of us for having a GUI, and while we can use the command line using the sc command to, you know, interact with services, just use the services GUI. It's pretty simple. You can edit everything through it. Usually works pretty well. And Linux config files. So you pick Linux. Usually you use Linux because you can do everything to Linux. Everything's a file pretty much. You have so much configurability, you can go insane at all the things you can do. Everything that, usually most of the config files for services are an etc / the name of the service. So, and it's a .com file, or usually if it's a daemon, it'll have a .d. Example of this might be Nginx or something, and totally not red team .d was not a service if you're a blue teamer. Don't worry, it's a service. Don't worry about it. Don't delete it or anything. Trust me. On Windows, we have config files. Mostly the registry is how we do configurations for services. You can also use that handy app I had an image of earlier. It's a lot easier to work with. Don't have to deal with all the keys, and it's pretty easy to edit your services through that. Core services now. This is a list of pretty much all the services, well, not all, but a lot of the services you'll commonly run into, especially in competition environments, that will just be running on your machines. They're pretty important, pretty useful. I'm going to go through most of them and explain what they do and how they work. And DNS. DNS is really important because it kind of helps you resolve names to IP addresses, like google.com to an IP address, because you can't really remember, you know, every single website's IP address. If you want to be like, oh, how do I get to google.com? It tells you your machine actually, hey, this is where you need to go, instead of having to remember and manually type in every single IP address to every, you know, thing you want to go to. There are two types, is recursive and iterative. Recursive will pretty much, you ask them a question, they'll be like, okay, let me go look for it, and here it is. Here's the DNS name for it, or IP address. Iterative will say, well, I don't know what it is, but here's who will know what it is. There are different types of records. Most of them are pretty important to know if you're getting really into DNS, and there's quite a few more. There's a whole protocol about it. Kind of heard that that's kind of the case, and just look them up. SSH, pretty much the most important one of the more important services during competition, helps you access boxes remotely. And if this is down on a cloud box, for example, a box you don't have physical access to, it's going to be pretty hard to, actually reach that. Have a pretty config file in /etc/ssh/sshd config, whole thing. Lots of different settings like permit root login, obviously, root being the most powerful user in the box. You don't really want to let people remotely log in as it. Many different things that might be important for injects, maybe like the banner setting, which is a common inject in most competitions. DHCP, Dynamic Host Configuration Protocol. It lets you dynamically assign IP addresses to hosts on the network instead of having to statically assign, go through each machine and give it, hey, this is your IP address. How that works is kind of through the door process. So when you discover when it discovers, the client first comes onto the network. When you boot up a computer connected to whatever network it is, it will be like, well, I don't know who I am, what I am. Hey, who can give me an IP address? It will broadcast that to the entire network. And so the DHCP request server will get that, and it will be like, oh, that's my job. And it will offer an IP address from its entire pool, be like, I can offer this through this. Here's an IP address that you can have. The client then gets that offer back and is like, okay, I do want that IP address. That would be great. Thank you. And the DHCP service is, okay, I see that you want that address. So I'm going to acknowledge that you have it and say, okay, this is your address now. And so now the entire kind of local network knows the IP address is related to this computer. Pretty much half of the net services class is DHCP. It's a pretty important protocol, and you'll probably get familiar with it at your time at RIT. FTP, File Transfer Protocol. Usually on port 21 by itself. It's usually plain text, which isn't very secure. You can use SFTP, which is a lot more secure. And there's some common FTP misconfigurations. During competition, you want to check these out. Maybe not let anonymous users log in, or let people change file permissions on upload, like, making their not malware executable and stuff like that. It's one of the more important protocols. There's mail. There's SFTP, which is Simple Mail Transfer Protocol. It's SMTP. It's on port 25. It's used for sending emails. So when you're sending out the email, usually you'll be using that protocol. And then POP3, which is kind of an older one. It's on port 110. You receive an email on it, but it's only for one specific client. So once you download that email locally through that protocol, it will be deleted from the mail server, which means you can only kind of receive it on a single client. Well, IMAP, on the other hand, which is, I think, a bit newer, you can use it to receive from multiple clients. So if you're accessing from multiple machines, usually you'd use IMAP. Our common servers for this would be like Postfix or Dovecot and MS Exchange for Windows. VNC, X11RDP, pretty high ports. Remotely, it's pretty much like remotely managing a computer, like SSH, remotely logging in, but it's like from a desktop environment. So you actually get a desktop of the computer you're logging into instead of just a command prompt, which can be pretty useful in some ways. RDP is a pretty nice, it's usually what Windows uses, and it's much easier and to use from a desktop environment, I feel, than command prompt. Databases. The two most popular are MySQL and MongoDB, but there's a lot more, like hundreds. Poor configurations of them is that sometimes they don't sanitize input or weak passwords. I mean, that's common for most services. And they're kind of chunky, and they have their own languages to interact with them, but they'll be an important part, definitely. Web. Ports 80 and 443. So 80 is insecure web, which if you ever like go to a website and it like will like have like a your browser might have like a red broken lock in the top left. It'll be like, oh, this is unencrypted traffic. That's usually because of sites you're running on 80 and will be an HTTP hyperlink, while on 443, that's where we'll have you like, oh, you're good, you're secure, it's encrypted traffic. That's HTTPS. We have an entire week actually devoted to web. It's probably going to be week 10, so come back in a few months. Also, there's a whole semester on web, which is CSEC 380, one of the, I've heard, better classes. And again, common problems. Other web servers are pretty cool. Well, IIS is pretty cool. It's on Windows, pretty easy to set up real quick. And Apache and Nginx, in my experience, have been the most common on Linux. So that might best be, from my experience in competitions, is those are pretty easy to just set up and run. But those are most common from my experience. And SMB, which is a share, like a file share, on multitude of ports. So on Windows, it's mostly 445. Samba and NFS by default don't require authentication. So usually you don't need to log in to access them, but if you should really set them up so they do. SMB share requires authentication, like Windows Kerberos, but it can be disabled, which is pretty bad. And during competition, you should look into that if it is disabled. They can be used for data exfiltration, or honestly, pretty rough time, definitely. Again, from my experience in competitions, I usually assume the SMB share is the most insecure. Here are different commands you can use to access such shares. Telnet. Again, please never use Telnet. It's not encrypted at all plain text. Some network devices might use it, but it's just use SSH. Is better in every way. If you can, just use SSH. It's not secure at all. Telnet is. Detecting services. So, to take advantage of poor configurations on most servers, you actually need to know what's running. Nmap is a great tool for this. You can scan, see what port is open on what machine. And so, for example, if you see port 22 as a TCP protocol open on a machine, you can probably assume SSH is running. Which then, if you have some exploit for SSH that you can use to get in, boom, you can use that. It's a great way to know what's actually on a machine and even know what's facing outwards. And if you want to see what services you found, just use Google to find that out. So once you have the info what's actually running, you can make a plan to exploit that. And again, that's Red Teaming 101. And again, we're plugging Junior Tech League. It's pretty important. Please sign up at that link below. And it's time for a weekly demo. Pretty much week 4. But before that,